Hello, welcome to the podcast that's explaining this next assignment here that is piggybacking off of this homework assignment that you need to have done first, which in this worksheet you are determining whether there's enough given information. And from the given information we mean when we look at the problem and the picture, like number 1 here. What we mean by given information is that when we look at the picture, it's given to us that we have some congruent segments, right? That's what these marks mean. So we know that segment AB is congruent to segment BC. That's what we mean by given, because we can see it in our picture. Also, angle ABD is congruent to CBD, that angle there, right? So that's also given to us. Okay, so based off of given information, also based off of 2 facts that we're looking to see if triangle ABD here, right? Triangle ABD, which is this left triangle, ABD, right here. We're trying to show or prove that it's congruent to this triangle here on the right, triangle BDC. And if it is, we need to state why it is, which is one of these triangle congruency combinations here that we talked about when we did this activity. If you guys remember, we had the triangle congruency theorems, and we had all the different combinations of sides and angles, the 6 parts of a triangle, the 3 sides, the 3 angles. Only 2 of these combinations didn't prove or didn't guarantee congruency, like angle, angle, angle. We can make triangles that have the same shape but not necessarily the same size, meaning smaller or bigger. And also the side-side angle combination could make a congruent triangle, but also we can make another triangle that wasn't congruent but still satisfied this information. Therefore, we say that it's not guaranteeing congruence. Okay, but we learned that the angle side combination, so if we know that 2 triangles have 2 congruent angles and a side that's not between the 2 angles, the triangles are congruent. Also the angle side angle, so here's 2 triangles that have 2 angles that are congruent and then a side, but notice the side is in between the 2 angles. Angle side angle, so we know the angle side angle. Also side angle side side, so all 3 sides of 2 triangles, if we know they're congruent, the triangles are automatically congruent. And the HL theorem, which is a special case of the side angle that's specific to right triangles. Okay, so if we know that the hypotenuse of a right triangle, that's the longest side of the right triangle, and one of the legs, if we know that 2 triangles share that information, then we know the triangles are congruent. Right? So we went through all that exploration a while ago before Christmas break. Then we did this assignment where we're using those combinations here, the ones that actually did work side angle side angle side, and the HL combination. If we knew that 2 triangles had this congruent side and angle combination, then we can guarantee that both triangles are congruent, meaning all 6 parts. Right? This is what we called the 6 for the price of 3 combinations here to guarantee congruence. So when we look at, say, like number 1, we know that side AB is congruent to BC, so these 2 triangles, this left one and this right one, have a side that's congruent, or corresponding sides that are congruent. Also, we have angles that are congruent here. So these 2 triangles we know have a side and an angle that are congruent. Not enough information right now to use one of these combinations because there's 3 parts to each one except for the HL, but that's only in a right triangle. But the one thing that we have to understand though is that when 2 triangles here like this share a side, notice both the left and the right triangle share BD, then we know that both triangles, if we were to separate them, would have segment BD on them, so therefore BD has to be congruent to itself. So we actually know that this segment is congruent to itself as well, which then we can say, yeah, triangle ABD has to be congruent to CBD because of the side angle and also this side here. So side angle side combination. So it would be satisfied by the side angle side combination, right? What I mean by that too is, like, if you look at number 5, for example, we have these two triangles here. Again, it's like number 1. It's just kind of turned to the side. We don't know the angles on number 5 like we did on number 1. But what I mean by the two triangles sharing a side, it's kind of like this. Right here. So here's the picture of number 5. But basically, if we were to separate the triangles out, right, this is what I mean. Even though they're next to each other and they're sharing the side, but if we were to translate the triangles, they would both have that side that they share in common. So we know in this case that this side has to be congruent to this side because it's the same exact side, right? So when we put them together, we know that that side has to be congruent to itself, right? Anyways, so that's what we did on this worksheet here. Now, some of these, like on number 5, let me go back to my Smart. We know that, this side here is congruent to itself. If this is a straight line here, and this angle is 90 degrees, we know that this angle has to be 90 degrees because 90 plus 90 add up to make 180, which is the angle measure of a line. Okay, so right now these two triangles that we have here have a side and an angle in common, but from what we call given information, there's nothing else that guarantees that these segments are congruent to each other. Yes, they look like it, but in geometry we can't go off looks. Okay, nothing tells us that this segment here is congruent to this segment here. So really, in this case, there's not enough information to guarantee they're congruent by one of those triangle congruency combinations. So in our homework assignment we said, no, they're not congruent, and we're done. But the real geometry question becomes, well, why? How come we know based off that we can't guarantee congruent triangles? What does that mean? Right? So that's where the activity comes in, where you're going to use this Geogebra program or app here called Problem Numbers That Couldn't Guarantee Congruent Triangles investigation. So we're investigating why these, on our worksheet, these problem numbers, plus a couple more, but I selected these ones. How come they don't guarantee congruent triangles? So what I want us to do for this activity is to show why we can satisfy the given information, but we can make triangles that aren't congruent to each other. Okay, so here's how the app is going to work. What we need to do, each of these problem numbers here, that's why it's called problem numbers that couldn't guarantee congruence, they came off of the worksheet here. So each number on here that couldn't guarantee congruence is on this app, like number 2, number 3, 5, 9, 13, and so forth. Right? And if you click the checkbox, it's going to pull up the exact problem. Right? Like here's number 2, and it looks just like number 2. Right? I just took a screenshot of the problems and put them on a Geogebra file. Okay, so you can change the size of your picture if you want bigger or smaller, whatever, by moving these points A and B. A and B define the corners of this picture. So what I would do is this: get your pictures so that they're big enough so that you can see what's going on here. Since we have two triangles here that we're checking to see if we have congruence, there's not enough information in this picture right here in this diagram to guarantee that these two triangles are congruent to each other, because all we know is that this side EF is congruent to this side HJ, and this side FG is congruent to this side JK. So that's like a side, and a side. But we don't have another piece of information to be a triangle congruence combination. If we knew like an angle in here, if we knew the angle F is congruent to angle J, then we could say yes, they are congruent by a side angle side combination. But we don't. All we have are two sides here. So I want to show that we can make, based off of a triangle that has a side congruent to this side and this side, that we can make a triangle that's not congruent to this. Okay, so that's the whole point. We're going to try to make triangles that satisfy the given information from the diagram, but force the triangle that's not congruent to the ones in the picture. Okay, so each of these, if you uncheck, check, these are just the different problem numbers. So your assignment is going to be to go through all these and construct from the given information a triangle that satisfies the given but does not make a congruent triangle. Okay, so I'm going to do number 2 with you, and maybe I'll pick another one for this podcast, and then the rest of them will be yours. We're going to take a screenshot once we make a triangle that satisfies the given but isn't congruent, and we're going to paste them in a Word document. So I'm going to get a Word document open while we're working on this. Okay, so let's do this here. Now, to start out, what I want us to do is, this is just a picture. GeoGebra doesn't know these points, so we need to make them on GeoGebra so we can manipulate them. So I'm going to go to my line toolbox here. In this assignment, you're going to use two tools from this line toolbox. It's going to be the segment tool, and then also segment with given length tool. Okay, so the segment tool we're going to use, we're just going to click on each vertex here with our segment tool to make a segment. Okay, so there's my segment. Don't worry about the letters of the problem. We're going to use, so that we can manipulate these segments here, we're going to use the labels of GeoGebra. Okay, so now I'm going to click on like this point D again, and then I'm going to click on G to make that segment, and then to finish up my triangle I'm going to click on E and click on C, and now I have a triangle here, right, with the segments that are just like the picture. Okay, so now the next thing that we need to do is, even though there is this other triangle in here, what I want to do is I'm going to make another triangle over here in the white space that satisfies a segment that's congruent to this segment here, and then make a triangle that's not congruent to either of these two. Okay, so to do that, we're going to use that second segment tool, which is the segment with given length tool. So what this is we can create a segment and we can tell it what length we want it to be, and we want it to be these segment lengths that we made over here, right? So grab your segment with given length tool. I'm just going to click somewhere to start, put an endpoint of a segment. Okay, and now it's asking me what length do I want this to be, and I want it to be one of these two. So I'm just going to pick one, maybe this short one right here. So in GeoGebra it's the segment CD. Again, don't worry about the labels of the homework assignment. Go off your labels of your GeoGebra points. So I'm going to make it the length of segment CD. So we have to use capital letters. So segment CD, hit OK. And now it's always going to make a segment that's horizontal here, but really what it made was a radius of a circle. So if I move my point G, it just stays in a circle here, right? And we know that in a circle all the radii are congruent, so no matter what orientation this segment's in, it's going to be congruent to this segment here, right? See what I mean? So we have a segment that's congruent to this segment here. Now I just need to make a segment that's congruent to this segment right here, DE. So I'm going to grab my segment with given length tool again. I'm going to make F the vertex. Excuse me, my baby's crying real quick. I'm going to pause this and then I will continue in a second. Just a second. Okay, I'm back. I'm sure to you there's no pause in your video, but my baby's good now. Okay, so back to the construction here. The next thing we need to do is make a segment congruent to the segment DE. Since both segments share this vertex, this point right here, then when I use my segment with given length tool, and I'm going to make it this length of DE, I'm going to click on F so that it becomes the vertex or the shared point between the two segments. So I'm going to click on F, make it the length of DE. Okay. So now I have a triangle here that has a segment congruent to this segment and a second segment congruent to this segment here. Now the last thing I'm going to do is grab my segment tool again, just the regular segment tool, and finish off my triangle by clicking on the endpoints. So now I have a triangle here that looks like it could be congruent to this triangle, okay, based off of the given information. But watch what happens here. This is why knowing that these two sides alone and these two triangles is not enough information to guarantee congruence, because now as I move one of these purple points, I can keep my segment length. Remember, these are just radii of a circle, both of these segments, right? But I can make different triangle lengths, right? Which can force a non-congruent triangle. So that's the whole point of the worksheet when we say not possible or not enough information to guarantee congruence, is because from this given info it's not guaranteed, right? So we can make all these different kind of triangles that guarantee a non-congruent triangle. Okay, so now you're going to hit your print screen button, right? It's above your backspace button. When you hit print screen, all it's going to do is take a screenshot of what you got shown there, just like this. So here's number 2, and you can see in the picture here that we have number 2 here. Okay, and we're done with that problem. We made a triangle, and when I look at it, I'll say, okay, here's your constructed triangle, and it's not congruent to these ones. Okay, so then we're going to hit space so that we can put our next screenshot. All right, now when you erase, I need you to erase what you did, but we need to keep points A and B because A and B define the corners of every one of these pictures. So you can go ahead and just delete. You can just select a lot of things here. I like to slide the picture all the way over and then just highlight everything that I made, and I'm just going to hit the delete button and delete it, right? So now I'm going to uncheck number 2, and then I can go to my next problem. Okay, maybe like number 3. Now number 3 I'm going to do with you, and then I'm going to leave you the other ones to do for your assignment, that you're going to keep putting the screenshots of your constructed non-congruent triangle in your Word document here. Okay, so oops. Alright, number 3 is interesting. This is a side-side angle combination that, remember, we said it can make congruent triangles, but it doesn't guarantee congruence. Alright, so is this thing going? Yep, okay, sorry, I didn't see my meter there. So anyways, let's construct a triangle over here in our white space here that has a segment congruent to this segment congruent to this segment here, and an angle congruent to this angle. So just like number 2, what we need to do is grab our segment tool, and I'm going to click on these vertices to make my segments. Right, so this segment here, I got to click on my new point D again, and then go to this vertex. I'm going to click on E, and then finish it at C. So again, if you grab your move tool and move your picture, we have a triangle that's congruent to the triangle from the homework problem. Okay, so now I'm going to grab my segment with given length tool, and since I have an angle in this one, what I want to do too, if you have your algebra window showing, I don't have mine in this podcast here. I want to see it though. So I'm going to click view and click algebra, but if you see yours, don't do that step. I just wanted to see mine. Okay, now the next thing that I want to do, since we have these segments here, let's actually show what this angle is right here. Okay, so I'm going to grab my angle tool. Remember, when we do the angle measurement, we have to click our points in a clockwise direction. Make sure your vertex is the middle point that we select. So what I mean by clockwise is I'm going to click C, then E, then D. Right? It's just like a clock. C, E, D. Now I don't care what the specific number of the angle is. I just care what the label is. So GeoGebra, when it labels angles, it uses Greek letters. This little letter here looks kind of like a funky little A. It's the Greek letter alpha. Okay, so when I construct this congruent angle here, I'll show you an easier way to do it instead of our congruent angle construction we were doing before. So now what I want to do is, since I have an angle here, we have to construct the two sides. One of the sides of the angle, this upper side here, is a side that I want to make congruent as well. So I'm going to start there. Alright, I'm going to make a segment congruent to the segment CE, and again I'm going off the GeoGebra letters, not the problem letters, CE. So I'm going to grab my segment with given length tool, and for orientation reasons I'm going to try to make it look like the picture, just so I know that I'm doing it correctly. So I'm going to click a point here to start my congruent segment. I want it to be the length of the segment CE, so I'm going to click CE, capital letters. It creates my congruent segment, and I'm going to grab my move tool and grab the purple point, since that's the one that I can move but it's confined. I'm going to try to lay it just like I would in this problem, right? So these kind of look like they're the same thing, just kind of translated, so that when I'm doing this I know that I'm doing the right thing. Okay, now the next thing that I need to do is I'm going to make this angle right here. Right? I'm going to construct this angle right here at point F being the vertex. Okay, so now since this angle here is labeled this alpha, this little a here, I'm going to in my angle toolbox, I'm going to click the down arrow, and notice under angle we have angle with given size. So this allows me to create an angle of any measure that I want to. So I'm going to grab my angle with given size tool. Okay. Now what I need to do is I need to tell Geogebra what the first side of my angle is, and it's going to be this side here. I'm going to, just like I did with my angle tool, I need to click on my vertex second. So what that means is I'm going to click on G first, then F to tell it Geogebra that F is my vertex. Now it's going to ask me what size you want to make your angle. I'm going to delete this 45, and I want it to be, I'm not going to put this exact number in, I'm going to put in the label of this angle. And since it's alpha, if you look on the right side of your input bar, this is your input bar, on the right side here we have the alpha symbol. So if I click on that, it gives me all these Greek letter options plus a lot more stuff. But I'm going to click on the alpha symbol since that's the label of my angle. And then now, since GF, the segment is the first side of my angle, and I want my angle to open up like this angle that I'm copying does, I really want it to open up counterclockwise, right? Since we're going here, CE, D, I need it to open up counterclockwise. So I'm going to make sure counterclockwise is selected and hit OK. So notice now all it is making a rotation. Notice our transformation notation. We have a G prime. It just rotated this point G, whatever this angle is. Okay. So now to finish off my angle, in the triangle that I'm trying to reproduce here with the given information, this segment right here, I don't care what length it is. Notice there's no congruent symbol there, so I'm not going to try to make it this length. So to finish my angle off, I'm going to grab my ray tool. And since ray is really half of a line, it's in my line toolbox. So I'm going to click the down arrow, click on my ray tool, and I'm going to click on the starting point of the ray, so my vertex, and I'm going to make it go through this rotated point G prime here. So I'm going to click on G prime, and now I have my angle. Okay. So notice as I move one of these points, notice as the angle changes on the triangle that I'm making, my congruent angle that I constructed is also going to change to that. Okay, so that's really what we just constructed. So this segment GF is congruent to this segment CE. This angle alpha is congruent to this angle, which is now beta. That's a Greek letter for beta. Looks like a B. So now the last thing that I need to do is construct a segment right here that's going to go start at point G, and then it needs to be this length here, CD. Okay, so I'm going to grab my segment with given length tool, since I'm going to copy a segment. I'm going to have it start at point G. It's going to ask me the length, and I'm going to make it length CD. Click OK. And now what I'm going to do is I'm going to move my point H, this new point here. That segment is the exact same length, but I'm going to move it so that it touches my ray, and then that way I know that there is a triangle, right? That has a side angle, side angle, and right now they look pretty congruent. So if I move this here, I would argue, like, you know, those look pretty congruent there. But the thing about this H swinging here and the segment's the same, nothing's constricting this angle with our combination here. So as I put H here, we have a congruent triangle, but notice as I swing H, it also touches my ray right here. So now this is a triangle that satisfies the side angle, but it's not congruent to this triangle here, and we can kind of see that. So now I just constructed a triangle that's not congruent to this one based off of the side angle. So that's what I mean by the side angle combination does not force congruence. Therefore, we can't ever use it as a confirmation of congruency. So now I'm going to hit print screen. I'm going to go back to my Word document, and I'm going to paste this number 3. Notice we have the number 3 from the problem on there. And then I'm going to move on to number 5. So I made a triangle non-congruent to that one. So again, what I'm going to do to get to my next problem, I'm just going to slide my picture with the points out of here for a second, and everything else that's left, I'm going to delete it, except for my points A and B in the picture. So now I can hide my number 3, go to the next problem, and construct congruent stuff here. Remember, Even though there's not a congruent symbol here on the segment, if we're going to try to show that these two triangles, this upper and lower one, are congruent, they both share this side YA, so therefore we have to make sure that we construct a segment of that length when we do this. Okay? And since this is 90, this has to be 90, so we have to make sure too that we construct that perpendicular line there. But try to, based off of that information, try to make another triangle that has a segment length that's this long, that has a 90-degree angle in it, but is not congruent to either the top one or the bottom one. Okay? So that is your homework assignment, and that is helping us understand what it means when we look at a diagram and we don't have enough information, because we're making triangles off the given information, but they're not congruent. So that's what we mean by not guaranteed to be congruent. So I hope that makes sense. If you have any more questions, please ask me in class.